Good morning, good evening, good afternoon, depending on the time zone and the place when you are looking into this assignment walkthrough. I, along with Raheel, would like to welcome you to the part two of Stream Processing Analytics assignment. Just a quick recap of what we did in the part one. Right, part one, the problem statement that was given: a startup company which is supposed to build a private community app and which can let you create multiple communities and the users can join them. It is going to be the like of Facebook. Such will be the volume, such will be the traction. A classic case where the stream analytics needs to be implemented because there will be a lot of flow of data that is expected to happen. Right, so this was the problem statement, and before we put on to the solution, the proposed solution, these were the various consideration that we thought to that. Okay, so it has to be instant, it has to be there should be some kind of analytics involved and a lot of offline processing that is required. So we recommended that okay, we'll go with Lambda framework, right? Detailed overview of the conceptual overview how it is going to get executed, and then this is the technical architecture that we propose that okay, at the heart of the solution it will be Kafka followed by Spark, Storm, right, and various data sources, be it relational, non-relational, and then followed by the consumption. uh, yeah, and since me and Raheel both come from Microsoft background, we thought, okay, let's why not to suggest that okay, how this is going to look like if in case the same solution has to be implemented using Microsoft technologies, right? So this was a quick overview. Uh, it's a zoomed in view of Kafka. I will not go. And yeah, this is the schema. It's very important because the same schema we have implemented in the part two. Right. Now let me start with the part two. And this part two, incidentally, it has got three subparts. Part one talks about the two different use cases: social media post, the entire workflow, message conversation between users and user groups, right? And it has to be supposed to be implemented using Kafka, Spark, Flink combination, depending on the choice of technology. And again, in the part two, the data that has been gathered, a stream analytics pipeline needs to be created, and a dashboard has to be generated out of it. Part three, the code submission. So in part one and part two, what we are doing, I will try to cover in this particular demo. This is the implementation view which we have implemented now, right? So starting from left to right, the data sources and the app that we have created, right, that is sitting outside the boundary of this stream analytics. It's pushing data. The data is getting absorbed by producer. We have created topics, and the topic is the producer is putting the data into topics, and then the consumer is picking up the data, right? And stream analytics, that association is taking place, and depending on the route that we have to take, the data is available for direct consumption to have the real-time analytics, and it is also available in MongoDB. That's the choice that we have taken, right? And then there is a dashboard. The entire Kafka is managed by Zookeeper, so we have created Zookeeper server, and then finally there is a reporting layer. So this is something which we have created. All right. So let me now take you to the implementation view. The putting up the infrastructure for this solution was in itself it was a task. So let me quickly talk about what we have. Right. So in order to run this program, there are certain services that needs to. So I have just to go back. Since I spoke about the infrastructure challenges, we have to put up a Azure VM. It was not working on my system. It was not working on Raheel system. It was quite a challenge for us. So we had to acquire a Azure VM, and we have put up all our software services into that particular VM. So essentially talking about these are the four different services which are required to be running in the backdrop in order to make this solution successful, or listening to the various requests coming and then consuming them. So we have got a master. It's the Spark Master and Spark Worker. These two processes are very important. So this is a Spark Master, and then followed by Spark Worker. Then we have the Zookeeper. Zookeeper is maintaining the cluster for the Kafka. And then finally Kafka as well, right? So these are the 4 different services, or you can call it as servers. They're running at the background. Now let me quickly talk about the code that we have. So this is the Solution Explorer of Visual Studio. Let me just quickly talk about what we are trying to do. So if you look at this, there are different pieces of code. And first, we are creating a topic. So if you look at this particular piece of code, we are establishing a connection with Kafka and creating this topic, right? If I go and run this, since this topic is already created, right? So it will not create it, and it will throw an exception. But let me show you the other parts. So the Kafka producer. So let me, and this is the dummy code which we have written to generate the messages uh, which are supposed to be consumed by the stream analytics pipeline. So let me just run this for your reference. So when I run this, yeah, so you see that okay, the message has been delivered. So anyway, what we have done is that we put up this message, right, and it has been relayed. Right, let me do this. Let me change, instead of my name, let me put it Raheel's name. Of course, yeah. So there is a mistake, right? And now it has been corrected since Raheel's, yeah, the gender is appropriately called out here. So let me run this once more and show you how the changes are reflecting in the subsequent layers. So I have to stop this, to go back. A bit little scattered overall environment we have. I wish we had more time, or maybe some better ways to contain and create a DevOps kind of solution where everything can be contained and deployed at will. But then never mind. I think the solution is pretty much running end to end. So when I ran this, so you probably would have noticed that okay, I have updated the name, and this is the message that I'm passing. You can put this. There can be multiple messages. You can put in loop, and the same messages can come from the outside community, or maybe the web app that are supposed to be written. Okay, now let me take you to Kafka consumer. This is again to demonstrate that how this particular piece, what is now put into the consumption layer, the producer has put this into topic. Now the consumption layer is going to pick up this data and pass it to the downstream. So let me take you to the Solution Explorer once more. Kafka consumer. Let me make it as a starter file. So we have used a combination of Visual Studio and Anaconda. Yeah. Let's just wait. All right. So now if you look at it, right, see, so earlier, since we ran this 2 times, right, so you probably will see that Arun Chauhan is coming here, and then we have got Raheel here, right? So this is showing that okay, how the data is actually put into the topic through stream analytics, and again how the data is getting consumed. So producer and consumer both are covered here. Now let me take you to the next step, which is the source code that we have. Now, okay, now you look at this. This is the same thing. That the piece that I showed you was primarily a demo one, just to make sure that we understand that how the data is generated, how the data is getting consumed or can be consumed. This is the real place where we are consuming the data. So here we are establishing a connection between Kafka and Spark, right? And all the libraries, necessary connection string, right? And the details which are required has been put into this into the code, right? And then a connection is established. Then the data which has been picked up from the topic or the consumption layer, it has been put into a schema, and you can see probably the count is the records, and then you can see the first record because we sorted this, so that's why we are Raheel is being shown in at the top, right? And then Once the data is available, we're passing it to MongoDB. So this is how we are doing it, right? So this completes the cycle where the data is picked up from the stream, from the consumption layer and put into MongoDB. So this is what we were supposed to do in the part one. So let me just take you back. Yeah, yeah. So this part one it covers this particular part. Done. Now let me take you to the next part, which is putting up a dashboard or do some analysis on top of the engine that we have created. So this is the reporting layer that we have created. And here we are establishing a connection with the MongoDB. I'll show you. We have created MongoDB as well, right? And here, so there are multiple storage databases, right? And then we are picking up the data which is available, which was posted, right? And actually, when you look at the data that we have submitted in the previous dummy or maybe the producer that we had created multiple topics, and their topics are distributed between science, literature, history, and drama. So what we are doing, we are creating a chart on top of it. See, we could have gone an extra mile, could have created a lot of things, right? But the idea, I believe, that is to show that how the analytics can be done, right? So this is a perfect way to show that how the data is consumed from the app, put into Kafka, from there how it is processed in Spark, right? And now how it is available in Python, and how it analytics can be performed on top of it. So this actually completes the part two as well. So you probably can see that, okay, how the data that we have posted, how it is giving a different pie chart, science, drama, and literature and history. So with that, the part two also gets over. I hope you like this, the overall implementation and the presentation. Uh, uh, I think with that I will sign off. I will sign off. Thank you so much for your time. Thanks. Bye.